Okay, everyone, so we're looking today at drawing charge distribution diagrams. So at this point, we would have learned about friction. So the ones that we're going to focus on today are friction diagrams. Now, whenever we're drawing charge distribution, doesn't matter the type of charging it is, we're going to follow a similar format. Okay, but all the ones we're doing today are focusing on friction. So this first one here, let me get my purple pen here. Okay, so the first thing you want to make sure you have while you're doing this is an electrostatic series chart. So the one I'm going to be using is this one here. This is from one of the worksheets that you have. Now it's very important while you're doing this to use an electrostatic series chart for the entire thing. So what I mean by that is we're going to be doing like 3 or 4 different examples. I'm going to use this same chart for all of them. You'll have noticed by now that these charts have sometimes different things than you would expect on other ones. So for example, this one in general has just fur or hair, where you may have some charts that have cat fur, rabbit fur, human hair. I almost said human fur. But when you're doing this, right, you're using the one that is provided for you. So when you're doing your homework and stuff, you're just going to use whichever one you'd like to use. However, for when you're doing a quiz or a test, you're making sure that you're using the one that's provided. So I will always provide one for you to use. So that way I know which different items you have. Okay, another thing to point out on this one, you'll notice that it just says plastic and rubber. And some electrostatic series charts will be more specific, like plastic wrap or saran wrap, or a plastic rod, rubber balloon, or a rubber shoe, or there's different types of rubbers as well. So instead of plastic, you might see polyethylene or something more specific. So this is why there's a lot of variation that goes here. So for this one in particular, for this lesson, I'm going to be using this chart. So just a reminder on how this works. The closer to the bottom of the chart that these items are, they tend to hold onto electrons or gain electrons. So the further down on the chart that a substance is, the more likely it is to be negative after a transfer has happened. The higher items in the chart, right? So the higher in the chart that it is, it's more likely to lose electrons, or they have a weak hold, a weak electron affinity. So remember that this also can be called an electron affinity, right? So a weak electron affinity or strong. So when you're comparing the two items that you're doing friction with, you have to compare them in this chart to see where they're located. Okay, so the first one here is already done for us. So we have a plastic ruler rubbed with a piece of wool. So we have plastic and we have wool. So at the start, you always begin with both items being neutral. Okay, notice that I'm labeling the things as well. So I have to say what is plastic, what is wool. Okay, now when you're doing your diagrams, it's important to be consistent. So I've used here 3 positive symbols and 3 negative symbols. Same for both. So right now there's equal number of positive and negative symbols, which means they're both neutral. Now, so this is like a before, this is like a during, and this is like the result afterwards. Okay, so during is when you're going to show the transfer of electrons. Now, normally I move 1 or 2 electrons over. You never want to be in a situation where you're moving all of the electrons. Okay, you should still have some left behind. So in this case, if I move 2 out of the 3, it's okay. I'm not removing all of them. So I usually use 3 positives and 3 negatives. I would say don't go less than 3 and don't do more than 5. It becomes too crowded, too cluttered, okay? But unless you're told exactly how many to do, and you may have an example like that, like draw a friction diagram beginning with 5 protons and 5 positives and 5 negatives, then you go with that. But if it doesn't say, anywhere from 3 to 5 is fine. Okay, so the reason why wool is losing and plastic is gaining has to do with this right here. So here is wool and here is plastic. So the wool is going to be losing, the plastic is going to be gaining, and that's exactly what's being shown here. So the end result is the plastic has now 2 additional negative symbols, and the wool has lost those 2 symbols. So the plastic has a negative charge and the wool has a positive charge. So you start off being neutral, you have a transfer, and then the after end result is the charge. Okay, so let's look at another one. So you can also try this, pause the video, feel free to pause the video and then give this a try. So we're gonna do here a balloon. So balloons are made out of rubber usually and wool. Okay, so when we're doing this, I'll do the first one with you. So this is our rubber balloon and here is our piece of wool. And we're starting with them both being neutral. So I'm going to do 3 again. Okay, so neutral, neutral. So if you'd like, try the next 2, but keep in mind, right, we already looked at this. The positive symbols should never, ever, ever move. So remember that those positives, oh, why is my pen not working? Uh-oh. Oh, okay, for some reason it didn't go. Okay, so the positives should never ever move. So remember that those are representing the nucleus of the atoms. So the nucleuses are not moving. So what's happening is your negatives will be. So here are our negatives. So we have to show, ooh, it's a little bit cluttered here. So anyway, so let's take a look at the chart. So the chart has wool and rubber in this case. Right, so wool, and we're looking at a rubber balloon. So in this case, the balloon is going to be gaining. So we can show a transfer here. You must show the arrows as well. So the arrows indicate the direction of where the electrons are moving. Okay, so this is going to be pretty crowded here. But, so we should end up having only 1 negative on the wool, and then just imagine 1, 2, 3, 4, 5. We have 2 extra negatives on the balloon. So the resulting charge is that the balloon is negative and the wool is positive. Okay, so let's try out the next one. A glass rod is rubbed with cat's fur. So, and don't forget to write the description of the event. So underneath each one, you should be saying what is happening. So give this a try actually. So remember, we're using this chart. Come back here so you can see this. Okay, so we're using glass and fur. So glass and fur. Okay, so give that a try. Pause the video if you have to. Okay, so we have neutral glass, and this guy is fur, neutral, both neutral, right? So this is before. Then we're gonna have to show the transfer. Okay, so because of the location, glass is going to lose electrons and the fur is going to gain them. So let's go back. Okay. Sorry. Okay, so my glass is going to lose them. So I'm going to show the transfer. So obviously when you're doing this, please draw it a little bit better than what I'm doing right now. Of course. So let's write a little description. So glass loses, my Apple pen just ran out, so that's why I'm writing with my finger, in case you're wondering what the heck. Her writing's already bad and now this is like a million times worse. That's what's happening. Okay, so glass loses electrons to the fur, right? So then here in this side, our end result, so So we're still going to have one negative. So the glass rod is going to be positively charged. And now we should have 2 extra electrons on here. Negatively charged fur. And then you would just make a little note. So the glass rod is positive, and then the fur is negatively charged. Okay, so there's 2 more that we're going to try out. So we have a gold bar rubbed with a piece of silk, which is repetitive to what we're doing, right? It's just new materials that we're comparing it to. And then there's going to be one where I'm going to have you draw it on your own. Okay, so we'll take a look at that in the next part.